All right, let's continue with iteration. Very often when you're programming, you would like to have a certain chunk of code executed several times, or a certain process of your data management being applied to, for example, several different data sets. So this is where loops come in. The way for loops work is that they take an index variable and apply it to each element from a range that you specify. And each time when they iterate through this, they execute the code that is written in the body of the for loop. So in practice, for example, our index variable is I, and we want to iterate over all the values from 1 to 4. And in each iteration, we want to execute the code that is written here. In this case, this is print the squared value of the index. So since we're doing this 4 times from 1 to 4, in the first iteration, I will be equal to 1. So we'll print the squared value of 1. In the second iteration, I will be equal to 2. So we'll print 4 as a squared value of 2, and so on. And I will do this 4 times. We can also iterate over elements from a vector. So for example, we would like to execute a certain operation on all columns that we pre-specify. So in this example, we import a data set, and then we define a vector of names with all the variables that we would like to have turned into vector variables. So for example, let's say you read in the data set and these variables come in as numeric values. For example, year is read as a numeric, but it should be a vector variable. So what you would do is you would take this vector that contains all the names, and then you would iterate over each element in this vector. So your index variable in the first iteration will be assigned the value person ID. And then in the body of the loop, what we do is we select the column from the data set person ID. So we take this variable person ID, and then we unlist it, turn it into a factor, and assign it back into the original data set. In the second iteration, we assign I the name year, we select the year column, unlist it, turn it into a factor, and assign it back. And we do this until we have exhausted the factor variable vector and essentially transformed all the variables that are listed in this vector into factor variables. So the map function is very similar, that it allows you to execute a function over either elements from a vector, objects of a list, or columns of a data frame, as we just did in the previous example. Map functions, they perform the same function as you would do in for loops. However, they often allow you to write code much more concise, and they often significantly faster than for loops because they run the entire iteration in the background instead of having it written in actual R code. And if you have been working with R before, you might have come across the apply function family. And apply is essentially doing the same as map, just map is an improved version of apply, a little bit more efficient, a little bit easier to use. So the way you use map is you give map the data that you would like to apply the function to. You give it the function, and then you have some additional options to that you can specify. But most importantly, you need to give the arguments data and the function that you would have to apply it. So in an example here, we subset all the variables that we would like to have turned into factor variables. So remember, if we give a list of names as an input for the columns in the square brackets, it will just select all these variables whose names were listed in the vector. And then this subset we feed into map as the argument for data. And then as a function, we supply as factor. And now, since map on data frames works, it applies this function to each column separately. What it now does, it just takes all these columns that we selected here, turns each of them into a factor, and then assigns it back into the original data set. So if you think about it step by step, it would, for example, take the person ID first, turn the person ID into a factor variable, and then put it back into the original data set as a transformed variable. Map by default gives you a list as an output. If you would like to have, for example, a vector of logical values or a vector of numeric values, character or data frame as an output, you should use one of these specific functions that give you the correct output that you want. So if you look at an example, here we take a subset where we select from this data set, where we select only the variables parent income, mother years of education, and GPA. And then we would like to apply the interquartile range to each of these three variables. So this calculates the difference between the first and the fourth quartile. And now we use pipe to tell map double that the input is this subset. And then it should just apply this function to each of these three columns. And since we applied map double, the returning data type will be a vector of numerics with these three entries. And if you just use the general map function, it will give us the same values, but it will return them as a list with 3 elements. So in this case, we will, for example, first have to unlist it and then save it as a new numeric vector before we could continue work with it. And using map double directly basically saves us the step of unlisting the list. Very often, we'd also like to use our own functions, not just a function that is already predefined. So what we would do is, instead of giving as a second input an existing function, we just write our own function right in there. And the way to do this is that you type function, you give it the input or the placeholder variable x, and then following in brackets, you write whatever operation you want your function to perform. So in this case here, we would like to have the C transform of each of these, the C transform function applied to each of these three columns. And if you remember, the C transform, what it does is it basically will take your column, calculate the mean, calculate the standard deviation, and then it will transform each value in this column by subtracting the mean and dividing by the standard deviation. And here we basically just define this function, like right as the argument for the second function. We take the placeholder x, subtract the mean of x, divide by the standard deviation of x, and the map function knows that instead of x, you should just use the different columns from the data argument. So it will be parent income, mother education years, and GPA. And for each one of them, it will calculate the C transform and then return a data frame, since we apply map data frame, called C transform. So oftentimes when we're writing code, we would like to execute parts of our code only if certain conditions are met. So for example, we would like to turn a variable into a numeric variable only if this variable actually has a quantitative interpretation. So this is where if statements come in very handy. An if statement allows you to execute a piece of code depending on a condition that you specify. So for example, here you write if, then followed by a condition, and this condition needs to be a logical value, so it needs to be either true or false. And if this condition is true, the code that will be written in the body of the if statement will be executed. So let's look at an example. For example, we want to go through all of the variables in our data set and then convert all the variables that should be factors into factor variables. We know that variable is a factor variable if its column names is contained in the factor variable list that we have specified earlier in this lecture. So what we do is in this loop, we loop through all of the column names. We check if this column name is contained in the vector with the factor variable names. And if it is contained in there, this condition here will be true. This means that we execute this line of code inside the if statement, which just converts this variable into a factor variable. If the variable that we're looking at is not in the list of factor variables, so for example, the wage would not be a factor variable, so it will not be in this vector, this condition here will be false. So we will just skip this step and we will not convert this variable into a factor. You can also have multiple conditions, and in that case, you would use a so-called else-if statement. What we do here is a very natural extension. We would first test if the first condition is true. If the first condition is not true, we will skip the code inside the body here and check the second condition. If the second condition is true, we will execute the code inside. If this one isn't true either, we will just execute the code that follows the else statement. So in this case here, we would always execute one of these three chunks of code, because else will capture all the cases where neither the first nor the second condition were true. Oftentimes, you would also like to apply a conditional statement to a vector. So for example, you have a vector and you would like for each element to be checked for a certain condition. And if it is true, you would want a certain statement returned, and if it is false, something else that you specified before. So the syntax is the following. You would type if else followed by a condition, and the condition here will be a vector where you basically check each element for this condition, and then it will return the true statement if for this element the condition is true, and if for this element the condition is false, it will return the false statement. And since we are testing this for each element in the vector, we will also get a true or a false statement for each element of the vector, and therefore this entire command will return as a vector as well. So to take an example, we sample from the numbers 1 to 30, 7 random numbers. We call this vector numbers. And we can see it here. There's 8, 20, 29, 28, 7, 3, and 13. And then we check in the if-else command whether each of these numbers is even or odd. And we do this using this modulus operator, and I recommend that you look up how the modulus operator works for yourself. If the number is even, it returns even, the string variable value even. If it is odd, like the third value, it will return odd. And it will do this for each element, and therefore we will also get 7 statements of whether the value is even or odd. If you would try this in a normal if statement, you would only execute this for the first element of the vector, and you will not go through all of the elements. What you would need to do in this example here, you would actually have to loop, you would have to nest this command inside a loop, and then loop through each single element of the vector, and then return, or then check this condition and return even or odd. Another improvement is if you have to test several conditions, you would want to use a case when command. And case when allows you basically to just list all the conditions that you would like to test and associate each with a statement if this condition is met. So you would, for example, have a first condition. If this condition is true, you will return the first statement. If not, you will go to the second and check this one for whether it's true or not. And if it's true, you turn the second, and so on, and you go through all the cases. And you will stop when one of the conditions is met. So here, for example, we again take the numbers vector that we just created, and then we will create a new variable called interval in this that we're going to append to this vector, and it will basically just bin the values into bins of range 10. So the first condition is if the number is larger than 0 but less or equal 10, it will return 1 to 10. If it's between 10 and 20, it will return 10 and 20. If it's between 20 and 30, it will return the string 20 to 30. So as a result, since we have converted numbers into a tibble, and then we mutated, meaning we appended this extra column called interval, we now have a tibble that first contains the number, and then it contains a character where it says in which range of size 10 this number is located. So the last part of the general programming chapter is going to be about functions. And whenever you find yourself writing the same lines of code or even copy pasting the same lines of code multiple times, this is when you would want to write a function. And the function basically just serves as a wrapper where you combine several lines of code, and then in the future, instead of copying these lines of code, you just apply your function, which makes your code much more concise and also much more readable. What you need to write a function is you need a function name, you need to specify the arguments, and you need to specify what the function should do with the arguments that you have provided. So the syntax is you give the function a name, and then you type function, you specify all the arguments that should go into this function, and then inside you provide the lines of code that you would like to have combined into a function. It is good practice to give the function kind of names that correspond to the action that this function is executing. So for example, if the function is converting a character into a numerical, you should maybe call it convert to numerical, or something like that, that makes your code or your function easy to understand just from the name. So here, let's look at an example. And before, if you remember, we checked the elements of a vector of numbers, whether each element is even or odd. And we used the ifelse command to return even if the function is even and odd if the function is odd. Now what we can do, we can just wrap this into a function. We call this function odd. It takes an object. In this case, the object will be a vector of numbers as an input. And then it just checks whether for each element, whether it's even or odd, and returns the output. The function returns the output of this command in here. So obviously, object is just a placeholder. From now on, you can apply your function for every vector of numbers, like no matter how long they are. And it would always just check for each element whether it's even or odd and return to you a vector of even or odd statements that is equally long as the input vector that is applied.